Hell yeah, we are getting started with the core group math questions. I've got the stream out, I've got Maple out, so we'll be able to see basically everything kind of associated. I'll make sure Maple's big enough, and then Alright. We start with a function of 3 variables. And I mean, firstly, we're going to start to see if we can differentiate by hand, and then see if we can differentiate using Maple. But I would assume that using Maple is a lot easier, because we just need to define some function xyz, and then differentiate 3 times. Right? Because this looks like a pain in the ass to differentiate. I mean, if I... like, you've got, like, quotient rule here. Actually, no. If you treat everything like... if you differentiate with z first, you kind of cut these out. Right? It does look like if you differentiate by z, you cut that out. And then you basically got that. Right? So you differentiate by z. These are 2 constants. And then you differentiate by y. And you've got that. And then you differentiate by x, you got that. So it should be 4. Oh, what the hell? Yes. I mean, I guess. Okay, I mean, well, I guess it's 4. Okay, second question. For each of the pairs below, V is a vector. Music's loud enough, but we don't want any copyright, so I'll just keep the mic close to me. For each of the pairs, you're only advised to select answers you're sure are correct because mark is calculated as the maximum of 0 and... Okay. For each of the pairs, V is a vector space over the field R and H is a subset of V. Select all pairs in which H is a subspace of V when using the same field of scalars and same vector operations. So, V is some vector space, right? X1, X2, Xn, right? That's 1. You've got the 0 vector. Basically, you've got the addition and the scalar multiplication. If I remember, this is what a vector space looks like. And then H is a subspace. Select anything where H is a subset of V, and it's going to be also in R. Well, polynomials where the polynomial has the 0 vector looks about right? V is P with a polynomial with at least degree 88, and H is some polynomial also in that such that P91 is equal to 0. So it has a 0 vector. I'm sure polynomial addition and subtraction works. P is this, such that the degree of P is 4. What? P, I'm pretty sure this means that scalar multiplication, everything gets transformed. I'm trying to remember. If we want to test subspace, right? We're testing for zero vector, we're testing for addition, we're testing for scalar multiplication. Okay, if we tested like P of X is larger than 0 for all X. Okay, if I applied a negative lambda to it, that would go down here, right? So it probably wouldn't work. So I'd probably say no to this one. No to this one. ADA, BDC, ABDC, and R. Probably. P76. P0 is equal to 76. And 0... I think this still contains a zero vector. So that's good. No. I don't think so. It doesn't. Values such that when you input 0 in place of X, integrable functions on the closed domain 1 to 2 with a 0. I mean, it looks like it's possible, so I've been checking alternating. V is R2. H is a vector in R2 with X, Y, and Z. Yeah, fine. No. Like, lambda equals 1/3. Then what if lambda's pi? Then not good. I don't know. Fuck, this is getting confusing. And the music might be a little bit too loud for me. Transposition of A is minus A. Dude, how would I know this? Such that this is all negative. Span. Oh my god. This is scary. I need to spot these, by the way. Let's just slowly spot them. Okay. Okay. So it did say that this is the correct answer. Okay. We said that this one would be wrong. So this one is wrong, which means we're correct. This one is this third one. We also say it's wrong, which is yes, we are correct. This one we say is true, the matrix, which is correct. V P76 such that P0 is equal to 66 is wrong, so we are correct. Integrable functions. Okay, we are correct as well. Oh, thank God. Okay. Let's look at these guys. Such that x and y are integers. So, does h satisfy the addition conditions? Oh, I remember now. Oh my God, I remember now. X something like this, you know? Y if you add them together, you still have them in Z. So that works. And if you multiply by a lambda, right? Sorry, if you have lambda x is equal to let so both x comma x1 are in Z. Then lambda, then let lambda in R. I'm pretty sure you could just like factor out lambda. What they're saying is like, I mean, I could argue that that would be true most of the time. We'll see. Okay, they said that runs impossible. Okay, so we'll circle this one. The fuck? So this is a no. This one is a transpose of A is equal to negative A. That sounds so wrong. I don't know how to test that though. This one also looks like it's wrong. That looks like a subspace as well. Okay. Second question. That looks like that's wrong. Okay, that's the correct that's correct. So this one I also don't know why. So I'm gonna ask chat why. This one looks like it's gonna be correct. And then this one looks like no. Okay. So we have our answer. We're going to choose this one, this one, this one, this one, this one. So that looks like there's a 0 in there. That doesn't look like you could have any negative numbers, which sorry, it breaks like the normal lambda ones. The matrix looks fine. Integrable integrable functions looks fine. This matrix we're gonna understand how, and this. Okay, we're gonna come back and we're gonna see why. One sec. I'm wearing something that's supposed to keep me warm, but okay. Let's ask chat. Okay, sorry. Hey chat. I know like they're asking us to go through kind of the subspace theorem tests. And I could see that like the first one the first tick. So this is a list of the correct answers. I was able to basically understand that if vector v was some polynomial of degree 88 at most 88, and then h was the set of vectors such that there's like this other one specific vector that evaluates at 0, then right there's an existence of 0. If you add two vectors in it, like a lot of the information is preserved, so I'm gonna be okay with that. The only kind of ones that I'm gonna question are the matrix ones, specifically the 6x6 matrix in the field of R, and then it's a matrix of A. It's a matrix A such that A transpose is equal to negative A, and I would not know how to kind of attack that question. Second of all, I want you to disprove the question where the V is equal to the field R squared and H is a set of vectors such that X and Y are integers. And would it be like if I had a certain lambda that is yeah, I would need you to kind of show me why, basically. Kill me now. Okay, we're just gonna have this up right now, and then we're gonna talk about it. They are skew symmetric matrices. To test whether H is a subspace, check these conditions. The 0 matrix transpose is still equal to 0 which is equal to -0. Okay, so that means the zero matrix is in H. Suppose A and B are in H. A transpose is that, B transpose is that. A plus B transpose is A transpose plus B transpose, which is minus A plus B. For the integer case, to disprove, it's enough to find one failure. Find lambda is a half. I guess you're right. Okay. Okay. The other ones are okay, you know, like P of X plus Q of X would still be P of Q of X, and then the lambda still gets preserved. The degree one is just like stupid. This one doesn't have a zero vector. Okay. Matrix one is the one that kind of threw me off. And so this said subspace theorem tests for this one would be zero matrix. How would I matrix of zero? Transposed is still equal to -0 transpose, which is equal to 0 transpose. So exists. Sorry, I'm going to then addition preserves, closure under addition, and you have A such that sorry A transpose is equal to minus A. Okay, let AT equals minus A, BT equals minus B, then A plus AT plus BT is equal to, so transposition, does it swap it around? Fuck, I don't even remember. These are some hard laws. I forgot. I forget. Okay, I guess you're right. It's been a while since I've kind of done matrix operations. With the addition of matrices, I could distribute basically the transposition effect, right? But if they were multiplied, then I would need to have a specific order from back to front. Is that correct? I'm talking about is like A B transpose is like B transpose A transpose or some shit. What's going on? Lagging. Do we have the notes for calc and algebra? Algebra. Oh my God, matrix. Thank God. Yeah. So it says this part. A, B, T is TA, but these guys are okay. These guys are okay. Um. Okay. Okay. Let's continue. Then you could say A plus B and then A plus B transpose would equal to A transpose plus B transpose, which is equal to minus A minus B, which is equal to minus A plus B. Right? Then closure, oh shit, closure under scalar multiplication. You've got some lambda in R, and then just like A, then lambda, and lambda A transpose is equal to lambda A transpose is equal to lambda minus A. No, sorry. Think about this. It would be like this. Then it would be like this. Then it would be like this. Is that right? No, they did it the other way around. They went lambda, lambda, minus A lambda, minus. So you want to show that this is true. So I need to show that I need to show that this is equal to lambda minus A, which is the same as minus lambda A. And that's also gonna be in V. Okay? And then the span one is like, I mean, you feel it, there's basically nothing wrong with it. It's just like some type of smaller subset of vectors. And yeah. I would just like gloss over this. Okay. Yes. Right, like lambda is pi and vector x is 1 0. Sorry. Just doing a lot of rough working. Okay. Then lambda x is equal to pi on, which is not in V. Yeah. Okay. Moving on. We have sum p of x to the a minus y plus r of z to the b is equal to e, an integer. This is either 1 or 2. 1 or 2. P and R are non-zero, and e is an integer, so we actually have a function of xyz, right? Is equal to sum px a minus y plus r z, and they say this has to be an integer. Harley looks at the first cross-section of z on the xy plane to find the value of e at z equals 0. Okay, we'll start with this idea. We'll start with the xy plane first. Ah! Sorry, xyz plane. X. Y. Z. Right? So if they're gonna look at the xy plane, they're just going to look this way. Right? So you're looking down. It looks at the cross section of x on the xy plane to find e, and it concludes that I see a negative 2. That's all I see. No, it's wrong. Oh, okay. I think they've given us the function. F of minus 1, 1, and 0 is equal to... no, but I don't have a p of x. What is this plot supposed to mean? It's a surface that looks like that? Weird. Because that's what it looks like from the top down, you know? And they're saying at y is z is 0. Okay, z is 0. We're looking vertically down, so this is what we see vertically down. Could it be 1 and negative 1? I don't know. No, it's not. Looks at the cross section of the S on the xy plane. Right? This is the xy plane. We're sitting on the xy plane. To find the value of e, and concludes that e is equal to... I don't get it. The hell? What do I remember from that class? What are the first few classes? Or are these, what are these called? Are these parametric curves? Is that what we're is this what we're gonna study next? Maybe that's why I don't remember anything. One sec. If it is, then I will skip this question for now because we've not finished the questions. We'll go through the lectures and we'll see. Um, Calc. The fuck. Okay, so next week we have parametrically defined curves, velocity, and averages. May that be something that has yet to be covered. So that is why.
Situation.
That does look like it. But I will chat GPT it for now.
Yep, to 2 pi. Around, well, for the surface area.
Okay, I'll just ask ChatGPT first. Or I'll search up the keyword of cross section. Where's my chat, bruh? Where's my chat, bruh? Yeah, I don't think we've done this. Is this content about parametric curves? I I don't know what the answer would be because I don't know how to visualize what they're talking about. What did they say E was? E is 2? I tried E is 2. Huh? Oh, what? No, I tried E is negative 2. What? So they start with Z is 0. They substitute Z in to cancel, and then you've got... Okay, it's like working backwards. You've got parabola alpha equals to 2. Where? Parabola alpha. It's a... Okay. Y is some p of x minus some integer. Oh my god, that's goated. The hell? Okay. So you start with... You start with z is equal to 0. Then p of x, px alpha, or a, minus y plus r times 0 is equal to e. So y is equal to, if you transfer this and then you minus that, pxa minus e. Then, given that alpha is equal to a 1 or 2, because it's parabola, this implies that a is equal to 2. So we'll do y is equal to px squared minus e. Then at x is equal to minus 1, y is equal to 1. So 1 times p of minus 1 squared minus e. Is that how they did it? Vertex. Vertex is that. So, okay, they just want me to look at this graph. And this is a y on x graph. And at x is 0, y, okay, okay. Then at x bằng 0, y is bằng 2, negative 2. So, minus 2 is equal to 0 minus e. And then we got ourselves this, which is e is equal to 2. Wow, cool, I guess. Okay, so a is equal to 2 because we did deduct that. Then they want us to find b now. Okay, I think we just do the same, right? We do the same. But with other functions. We'll start with we'll look at this one, right? This is a z to y plane, right? Yeah. At zy plane, you've got x is equal to minus 1, y is equal to 0, and z is equal to 0 as well. We'll just, yeah. Sick. Then we have p p of 0 Sorry, p negative 1, is that right? Yeah. And this is, you call that a parabola, right? Jeez, this is fucking tough. Minus y is equal to 0 plus r0 b is equal to e. A must be a the hell? Then at x is 0, y is equal to minus 2. At x is minus 1. It's in my room! No, I haven't folded it yet.
No. Task.
I didn't, man. Alright, you guys.
Great.
Just watch Spider-Man, man?
No fucking way!
Dice, pues
Guys, I'm streaming math.
Oh, no, please don't.
Guys, wanna study math?
Oh, no, I'm scared.
Wanna watch my
Just
stream?
close your room.
Crying. Oh, sorry. We've been given x is 0 and y is minus 2. We can extrapolate. Because we have e is 2 at z is 0. Right? So we know y is minus 2. And e is 2. And x and y is 0. Think. Z is 0. I mean, this is tough, bro. Kanya. Here we're given x is 0, y is minus 2, and z is 0, and then e is 2. Right, so that function 0 minus 2, 0 is equal to 2. We've got a is 2 now. So we'll just play with a is 2. Right? And then a, so p of x, sorry, px2 minus y plus rzb is equal to e. Okay. What else could we play with? I mean, it would be smart to use this one, right? What could we isolate though? Is b equals 1 or 2? That means we have to isolate, we have to keep z alive. But here z is not alive. There's no... Oh my god. -1. x is minus 1. So it's equal to p minus y plus rz. Okay, then given x, then p minus y plus rz b is equal to e. Then at x is minus 1, y equals z equals 0, right? Or is it less than 0? Could I do anything about this? X is equal to 1, y is equal to 0. At x is equal to 1, y is equal to 0. Also, judging from here. Maybe that's something good? Because now we have e, right? Yeah. Oh my god, goated. Goated. Do we need to find x? Okay, it's okay. We'll try it. P 1 squared plus minus y plus r 0 b is equal to e. P is equal to e. Oh my god, I'm a fucking dumb. This is getting confusing. This is the second block. I mean, now that I know that x is equal to 0, when x is equal to 0 on the xy plane, y is equal to minus 2, right? That helped me solve a lot of stuff. Wait. Y is 2 constantly. No. No, y is not 2 constantly. It's a function of 3 variables. Function of 3 variables. Yeah, when y is z, when z is 0 and x is 1, y is 0, we could find something else, right? We find something cool about x. But we have a p there. Then p is equal to e. But we don't know what e is at that moment. Hey, would e be constantly... Okay, don't solve anything else. Would e be constantly at 2 when we evaluate z at 0? So I would be inching forward to find like when y is 0 and when x is 0, so that I can solve other values, right? Is that right? But would e continue to stay at 0 with z equals 0? Let's say I continue to look at that graph x is equal to 0, y is equal to negative 2, or x is equal to 1, y is equal to 0, or x is equal to minus 1 and y is equal to 0. Would big E still stay as 2? I guess, right? I mean, if you slice open this shit. Let me draw a better surface. You know what I mean? How do I add some three-dimensional depth? Okay. Okay. That means E continues to stay at 0 at this moment. Then E is equal to 2 is equal to no. At x is equal to 0. Sorry, x is equal to 1, y is equal to 0. Then 2 is equal to p 1 squared minus 0 plus r0 b. So p is equal to 2. And that would probably be my second guess. What else could we extract? That's all we could extract from that, right? Now that we have p of x squared, 2x squared, minus some y plus rz, we have to find b. And to find b, we want to find when z equals something valid, so that we can find b. I would not be able to. How? It's a mala. Oh my god. Thanks, baby. Thanks, baby. B is equal to what? Could B be equal to 1 or 2? That looks like it crosses the whatever. So I'm going to give it the benefit of the doubt and go x minus 1 is equal to z is equal to 0. Right. Then, yep. Let's do this first. A is 2, good. B is larger than 0, good. P is also, okay. Now we have B and R. if we think about it correctly, we can get it. But we need to find a time and place where x is equal to 0, which is right here. So let's maybe not look at this for a second. If z is equal to 0, e is equal to 2, a is equal to 2, p is equal to 2, then we have 2x squared minus y plus rzb is equal to e, and at f of 1, 0, 0, that equals to 2. Which implies at that oh yeah, z is equal to 0 that moment already. Think of what you can do to get b. Think of what you can do to get b. Z is equal to 0, 0. Z is equal to something there, but I don't have anything there. I don't have anything there. Would that be the only case where it's a parametric curve? Or so it's an implicit plot curve? Fuck. Which one? Some x plus y. This is some z to y. Okay. Guess we have to use this one. Right? At x 2 times minus 1 squared minus 0 plus 0 is equal to e. Okay, okay. So at x is minus 1, y is 0, z is 0. And that's equal to e is equal to 2 again. Okay. Give me a value of z that's non-zero. Sorry, that's not what I meant. Give me a value of... Is there a moment when x is 0 and y is equal to 0? And what z would that be? Shit, man. 可以找? I've next found out that I mean, when I look at the far left-hand curve, I see that x is -1, then y is 0, and z is 0. E is still equal to 2. But I don't have any other points to kind of base off of to find b and z. Where would you spot b and z here? Stuck with something. I don't know how to find that curve. Yeah. If b is, look at the shape. The YZ cross section would be a straight line. So you say b is equal to 2 right away? I guess you're right. Fuck. Oh my god. Curve. Okay. Curve. Wait. Sum z and y. And b is 2 because it's a curve. Because it curves. Okay, if I was given that, I'd be okay. If b is equal to 2, does it help me find r? Does it help me find r? How do I find r? R, my day. I need a moment where x, y is equal to 0. Or x is something and y is something. Yes. No. It's asking if r is larger or equal to 0. I don't know yet. How do I find that p is larger than 1? Because it had x is 1 and y is 0. Then we have x is -1. My god. Okay, now I understand that. How would you get r? Would it be that because it looks like it's expanding in the negative direction, r is going to be less than 0? So tough. Whoa. What call? What call? Third question, bro. Jeez. After substituting the known values, the curve has the form y is equal to z. R, rz squared. How? Rz squared. Known values. What do you mean? Like at x and y equals 0? Or what? What do you mean the known values? Are you talking about the known values of which known values are you talking about? Any known values? like x is -1 and y is like what values are you talking about? It's a pain in the ass already. Jeez. Okay, I guess you're right. Yeah. Okay, when you interpreted that graph, did you need the middle graph or anything at all? Or no? Y is equal to 1? Or would it be that like that graph just is there anything that I should know about that those curves? The last time I've ever looked like we've kind of touched on these were like hyperbolic functions, you know? Or like they used to move like this. Shit's tough already, bro. I'm ready I'm ready getting cooked. And fucking whoever, fucking Terry, he's on question 19. Oh my god. Oh my god. Okay, so this graph tells us tells us a x squared minus b y squared z squared is equal to c, which tells us the sign. Okay, so e is 2, b is 2, p is larger than 0, r is smaller than 0, and p is strictly larger than 1. Okay. Oh, what the fuck am I? Oh. Okay, this we can delete. Okay, using Maple. Let's play some music. I already feel tired. Can't believe he's so far ahead. I mean, what's the goal tomorrow? More of this. Saturday is more of this. Sunday is 2020 papers. If I can finish like 4 to 5 more by like 2 to 3, then I'm set up for tomorrow to kind of finish everything. Right, we have that COM 1100 test. Fuck. I do have to prep for that test. Pre-lecture content is stupid. Okay. Where's my music? Use the correct Maple syntax to input your expressions of vectors. Their images. Consider a differential function big F with two variables x and y near the point A, B, and the value of the function fab, which is probably that black blob. In the left picture is shown the cross-section of the graph Z with the plane y is B and the right is plane A, x is A. Right. Fuck. Wow, these are some gnarly questions. The tangent line to the curve of the cross-section at AB, FAB, has a slope of minus 3.7, and the tangent line to the curve of the cross-section in the right picture has a slope of 2.2. Which equation best describes the curve of the cross-section shown in the left picture? Let's see this list. Some A, some B, some Z. Okay. It says B, right? So it's Y is FBA. Plane Y is B. Plane X is A. I'll start with Y. Okay. B. Z. F of X and Y. X and B. Z. A. Y. Okay. How parallel to the tangent line to the curve of the cross section with the slope equals to minus 3.7, and we have some function of f of ax plus b, then that vector would be x. Wait. Tangent line df partial derivative of x here, partial derivative of b here, and minus 1 is equal to slope I can't write partial diff, right? I get it, so okay, I'm at question B(I), so B1. It says find a vector parallel to the tangent line to the curve of cross-section AB, function AB in the left picture, right? And they've given me the hint initially that z is some function of x and b. And I do know that the tangent line is equal to negative 3 point the slope. The slope is equal to negative 3.7, and we also know that the tangent line is equal to the derivative, or the partial derivative of f with respect to x, partial derivative of f with respect to b, and minus 1. Is that right? How did I come up with this? Oh, my feet are freezing. My feet are freezing. My feet is freezing. My feet is freezing. you again. What? Not the. Fuck. Not quite. The vector fxab fyab is the normal vector. Normal. Oh fuck. Right. The cross section is taken in the plane y is equal to b. So y stays constant. It's like they cut b right there, and then they show me what that looks like. Right? I've got the b, and they've chopped this image of that curve, and now they've only shown me kind of this part. Okay. Okay. I could live with that. That's the normal vector. Fortunately, the curve is parameterizing it. Is this a parameterized curve? Question. So would you think that it would not be in the specific content that I've been learning for now? Furthermore, would it be an algebra question or a calculus question? Babies and I, the creeper across from so dance, 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 dance. Light of the light, space and I. Have we done this? It's like, it's kind of hard, bro. They've done linear approximation, so this is one of the early questions then. Okay, you know what? I'll just learn it because it's a fucking whatever. So you have y is b, you have z is f of x of b, you have some r of t, differentiate r of t, and you've got that bad boy. Okay, whatever. Finding parallel, finding vector parallel to What just happened? Some function of x and b. Okay, I could live with both of this. Parameterize. Let x is equal to t and r of t is equal to some vector t b. This is the only part I've never seen this before. Is this something just fundamental that I need to know right now? Oh my god. I don't know. T, B, F, X, B. FTB, sorry. Will be at Y. Dude, if I understood it, I would, but I don't. So we'll just go through it. Then RT. So they differentiate RT. Whatever. Why is it not T? F. I could live with that as well. Given slope. It was do the same process for BII. Perpendicular. given y is, sorry, x is a. Fixed. So it's fixed at a point, it's fixed at a point A. And we're looking at this graph from like that perspective. Fixed. Then we have we have x is a, we have z, we have curve is equal to a function of, a fixed at y, and rt is equal, and let's do s. Y equals s. Why the fuck not? Rs a y, right? As f a y f a s r s 0 1, and then since f of y a s is equal to, I don't know, fucking 2.2, slope perpendicular is equal to minus 1.2 over 2. So let's do that. 1 over 2.2. Zero 1 open bracket minus 1 over 2.2. Close bracket. First one is 1 0 3.7. Pain in the ass. Whoa. My bad. My bad, bro. Minus 3.7. Okay, good. Okay. So we've got our correct answers. And we've got our z is f of a, y, and z is f of xb. Imogen wrote down an equation for the tangent plane to the surface. Tangent plane. But they have forgotten what values they had found for vector c. This is looks like a, what's that thing called? Or whatever. What might their vector have been? So you're telling me to find some vector so that I don't know, well, x minus a times c1 plus y minus b times c2 plus z minus fab c3 equals 0. The fuck would I know? What? I have no clue what they're asking. Normal. What do you mean normal? What's that fucking... What's that shit called? Point normal. Oh my god. Point normal. Wow, this has been a while form. I guess we could find fucking the shit that we talked about. Oh, we're gonna cross multiply. Find a, this is basically a triple scalar product, right? Given v1 and v2 in their respective planes. In the tangent plane. We want to find that third plane. I can't draw this anymore. It's okay. I'll just draw the boom, boom. And now we want a plane that's perpendicular to both. Given v1 is equal to 1, 0, minus 3.7, and v2 is 0, 1, 2.2. Using Maple, we compute the cross product. We compute the cross product. Okay. First day on Maple, let's go. Okay. Some vector v1 is equal to 1, 0, minus 3.7. What's going on? Some vector v2 is equal to 0, 1, 2.2. What's going on? Did I just go Chinese mode? Yep. Okay, then we have... Come on, bro. Then we have with linear algebra cross product v1, v2. No, it's a... How? I don't know. I honestly don't know. Integer components. Oh my god, motherfucker. Scale that motherfucker up. But so multiply by 10. This is one of the first classes, linear approximation. Oh my god, this is so hard. What the hell? I'm just... I don't know any of these. Jeez. F of x of a of b... Okay. Okay. Times delta x. And delta x was what, 3.7, was it? No. Delta x was a minus 0.5. My god. Okay. Given f a minus 0.5, b plus 0.6, change in x, change in y, then delta f is partial derivative plus and we should know that because of oh my god, crazy. I guess there were a ton of questions that I could have done, but I didn't ever do. Was it? This is how they find the tangent plane? Z plus that times delta plus that times delta. Just a normal vector and equation of tangent plane. Normal vector is that. Error estimates is that. Curve is that. Oh, okay. I should just remember this, eh? Two vectors on the tangent plane. In the x direction. This is this. Okay. 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 I remember a little bit more now. If they did it like this, I'd understand. Okay. If we strip away of everything we've ever studied, that is not so bad. This comes directly from here, and point normal form C comes from here. And then we also had this one. Linear approximation is delta z is equal to this, what is what they've given us, but it's also estimated to be this. So this is the direct one with no absolute value. This one is the max possible. These are direct errors. Okay. It was all good content that I started out with. But as the term went on, you know, you slowly kind of pissing off. Okay. So this is the direct one. We've got 3.7 plus 2.2 times 0.6 is equal to something. That is equal to, well, it's a calculator work, but coming up with this, that was so many things jumbled together that I would not be able to know. Well, and it's wrong, so. Minus 0.5.
Whoa.
3.17. This is minus 37, 22, 1 out of 10. Jeez, brother. 37 minus 22, 10. Okay, let's just make sure we... Okay. Okay. In the Y direction, minute. In the X direction. Okay, not bad. That did take a while. The vectors are shown in the interactive plot. You can use the sliders to rotate the plot and hide individual vectors in plain span by pairs of vectors using the buttons provided. Some subsets of S form a basis for R3. Oh, this is purely algebra now. There are exactly two subsets of S containing three vectors that do not. There are two subsets of S containing three vectors that do not form. In the list to the left of the plot, select two subsets that do not form the basis. This is sick. Okay. These guys are... So we're looking for things that are like scalar multiples of each other. Oh, now I'm just cooked. Sorry, that's where we are. Which one's a scalar? They all lie on the same plane. That doesn't mean anything though. Okay, let's check V1, V2, V3. Okay, we have V1, V2, V3. V1 and V2, sorry, V1, V2, and V3 are in this one plane. So that's not good. V1, V3 is in this plane. That's not good. V1, V4. V1, V2, V4. So we see that both V1 and V4 create the XY plane, and V2 creates the third dimension. Whereas with this one, they all create only a 2D. There you go. They only create 2D. So 1, 2, 3. Is there anything else? This 1, 2, 5. 1, 5 here and 2. That's 3D as well. 1, 2, 3 once again. Bad. This is, we're checking 1, 3, 5. Sorry. Let's check 1, 3, 4. Have we checked 1, 2, 5? Yes. So that clears 1, 3, 1, 3, 4. We're trying to check 1, 3, 4. 1, 3 there and 4. That's fine. 1 through 5. That's fine, right? This goes in the XY direction. This one goes third dimension. This one, 2 and 4. So 2, 3, and 4. We're chill. How about 2, 3, 5? 2 and 5 and 3. That's fine. 2, 4, 5. 2, 4, 5. Let's look at 4 and 5. This is 1, 4, 5 right now. That doesn't look good. 1, 4, 5. Wait, I'm goated. Okay. Okay, that's fine. 1, 2, 3, and 1, 4, 5. If the vectors... Oh, what happened? If the vectors line up, then you know they line up on the plane, then you know they don't span the third dimension. Also, we've got the V1, V2, V3 here. So I should have utilized that, you know? I should have taken this off, and I should have looked at like that. Boom. Then I check like 1, 1, 2, 4. I see we're chill. Right? 1, 2, 5. We're chill. 1, 3, 4. We're chill. Right? 1, 3, 5. We're chill. 1, 4, 5. Oh, that's not good. Yeah, okay. I cannot use a 1, yeah, I have to use a 1, 4, 5. Right? 2, 2, 3 now. Take everything off. I do 2, 3, 4. Right? 2, 3, 5. Now I do 2, 4. 2, 4, and 5. Right? 2, 4, 1, 3. Okay. We chill. That was sick. Lens and Tamzid were given 4 sets of vectors in R2 or R4. Okay? So you got... And what we do know is that... I mean, these 4 vectors... Maximum 2 of them are linearly independent, right? So... And in R4, this means that this one could not span, but could not span all of R4, but could be all linearly independent. Could span R2 because number of vector is larger than 2, but could not all be linearly independent. In each set, the vectors are distinct. For the first 2 sets, they are asked to determine if it forms a spanning set for R2 and prove their result. For each of the third and fourth sets, Lance and Tamzid are asked to determine if they are linearly dependent, or independent. Okay? So Lance and Tamzid thinks that U1, U2, U3 forms a spanning set. They could check that. Well, a spanning set means... It has to span R2, right? So it's not a linearly dependent thing, it's a linear combination thing. For some, yeah, like that. Yeah. For every vector, right? For every vector x in R2, we have some type of lambda 1. So like they're saying for every vector that's in R2, we could use these vectors to make sure that we can create it. On the other hand, Lance and Tam thinks that is not a spanning set. They could check that there exists a non-zero vector such that there are no choices. Okay. There exists some y in R2 that is not equal to the zero vector such that mu1, so there is no mu1, mu2, mu3. Like basically you've got these 4 building blocks of vectors, right? You've got this baby vector, this other vector, this other vector, and this other vector. Now like, hey, okay, if I give you this set, arbitrary vectors, you know, they could be all in the same direction. So this one, these guys could be parallel. But like, okay, if I give you some vector y, I give you anyone in R2, could you create it? If not, then it's not a spanning set. If it is, then yes. Okay. Shit. Okay, let's continue. Lance and Tamzit think that y1, y2, y3 are indeed linearly independent. To prove this, they could check that. Well, independent means, well, these lambda have to be equal to 0 if they want this thing to be equal to 0 vector. If vector is equal to 0, then only if yep. Okay, I should write a vector v, my bad. Vector v equals 0. Okay. Ugh. Okay, I could show you guys what I've been looking at. This is what we've been doing. But it's basically the same thing with endorphins. Endorphins? Yeah, endorphins. Endorphin mixing. Less than times the thing that x1, x2, x3 are linearly dependent. That means you can create something. They're Do they, assuming that length and tangent are correct, select the true statement below. It is possible for U1 and U2 to be bases of their respective bases. No, because basis is spanning and linearly independent. So this one is 3 vectors and it's less than R4, so you can't get, and this one is 4 vectors, which is way more than R2, so cannot be linearly independent. Could we say it's this one? Yes. Set U1, U2, U3, U4 has 4 vectors and for a basis to happen. Oh, let's actually read the algebra notes because I've actually not read the algebra basis. Ah, shit. Is linearly independent. Yes. So we start with this, right? And that has 4 vectors, and since it has 4 vectors in R2, this must mean that there are possibly vectors that are redundant because a basis of R2 would only need 2 vectors. So this set cannot be linearly independent, or the dimension of the set is too small compared to the number of vectors. Is that how you could write it? I need my foot warmer, bro. Sorry. We're going back into basis. The dimension of a vector space is the number of vectors in any basis. Of the set of the dimension of the vector space R2 is the number of required vectors, which is 2. For set y1, y2, y3 to be in fucking to be a basis for R4, it would need at least 4 vectors to span the whole dimension, to span the whole of R4. But it only has 3 vectors. But the set only has 3 vectors. That. Okay, something like that. A basis must both be linearly independent and span the vector space. The set cannot be linearly independent because dim R2 is 2, so any set of 4 vectors is linearly dependent. The set y1, y2, y3 cannot span R4 because at least 4 vectors are required to span a 4-dimensional vector space. Therefore, a set can be a basis for its... Nicely written, I guess. Give it to me. Give me the normal text, not with math in it. Not with LaTeX. Okay, I'll just keep it there for now. Okay, we're looking at polynomials and RREF. I think I should still do the Mobius. Nah, not really. Let's go for the fucking questions. But the Mobius would be good. You know, if I was the student that I am, I would do Mobius. Okay, function e1 of x is 1, function of e2 of x is x, and function e3 of x is x squared. And you've got those guys. Oh, sorry, e1 is... is this like, is this that shit? Maybe? Okay. So you see 2 leading columns. Two pivots, and two of these are leading columns, okay? Select all options that have a correct statement. It is a, this is polynomial at most 2. So it is a linearly dependent set. Because it has more than one non-leading columns. I'll start with that. So it is a linearly independent set because, nope, we're gonna kill all the ones that says independent. It is linearly dependent because it has a 0 row. Valid. A 0 row. Signifies dependence. It is a linearly dependent set because it has more columns than rows. I've never thought about it like that. Holy shit. Where's set A and set U? Okay, because this one says set A, then it's wrong. Wow, I did not think about this like that. One or more 0 rows. Okay. I guess not. Could that work? Just 2 of these guys? Okay. Okay, why? Could it not be that if... Like, I'm trying to find linearly dependency, and then if the matrix has a row of zeros, would that not mean that it is a linearly dependent set? Because there's no, like, there's no pivot in that row. Why is it wrong? Is the question. There's no pivot in that row. Columns are independent. Okay. So it doesn't span. It doesn't span. Okay, so it might not span the whole codomain. only tells you that it doesn't span the whole domain. Let's say we had for some a x is b, and we've got a is a function of r2 going into r3. Right, because this is a 2 by 3, and we're going to multiply by a 2 by 1. Oh, a 3 rows, 2 columns times a 2 rows, 1 column gets you a 3 by 1. Spanning, okay? Spanning set. Okay, let's look. P1, P. So it looks here that it doesn't span. So it doesn't span. Right? Because we have now found out that it just doesn't span. So we're just going to take away anything that says span. Wait, P2. P2. No, it doesn't. P2 is x squared. Polynomial 2. P2 has column space 3, which is 1x and x squared. So it does not span because it has this, and it has more columns than rows. I don't think, is it just one? Maybe? That's it. Nice. Why you gotta click so much when there's only one? Write then the dimension of the span. It looks like 3. Sorry, 2. Right, span of the image is 2. 2. Dimension of span of the set is the same as the rank. I'm pretty sure. Rank of set. Is the dimension of the span of that set the same as the rank of that set? Span is the image, basically. So yes, I am, yes. When you place the vectors, the rank tells you how many linearly independent directions the vectors can produce. 4 vectors in R2 might have rank 0, 2, 1. Okay, whatever. Find a subset which is a basis for P2 and contain as many of the possible P1, P2, P3, P4. So they're saying, okay, well, we have, this is P1, P2, right? P3, P4, E1, E2, E3, right? And I'm assuming we're going to take E3. But this is a pivot column, this is a pivot column, and this one is the first pivot column. So we're going to use this one. So we're going to use E2. We're going to use P2, and we're going to use P1. So the rank is here, my bad. And this one should be P1, P2, E2. P1, P2, E2. Okay, let's move on. E1 is the standard basis of R3. So, right, and then TE1 transforms to -9 and 2. We know that, and we also know that T of 0, 1, 1 transforms to that. Using the information above, compute the following or state that there's not enough information by giving the word undetermined. Could we create some type of vector here that, some type of matrix here that could do that, or do we compute it by hand? If there was a better way, you know? The goal would be to have like T something minus T something gets us whatever those vectors are. Pretty sure we could just, I mean, because this is E1, right? Okay, if you I think the first two are undetermined. Okay, okay, that one's undetermined because E1 is 1, 0, 0. And how do you take that away? T0, 0, 0. Would T0, 0, 0 give 0, 0, 0? Yeah, it would. And T1, 1 would give, well, the addition of that. Okay. Right. So some matrix times 0, 0, 0 would give 0, 0, right? It's some A, B, C, D, E, F matrix, right? quadrilateral ABCD. Image of ABCD. Find the coefficients alpha 1, beta 1, alpha 2, beta 2, such that ID. Where's 1, 0? That's B and that's TB. Okay, so I see like see what's a point? Point C, point D. Well, point B got moved from here to here. Point C got moved what the fuck is that? Is that point C? Okay, it does look like it's just a, not just, but it does look like a flip. They just like flipped it like that. Right? Like A would like be like here or some bullshit. One zero is alpha 1 plus beta 1. 0 1 is alpha 2 times beta. Is there a place that we can find 0 1? Nope. Nope. We could do B is equal to minus 4 3. TB minus 3 4. Okay. That's the vector. That's the vector B. That's this vector. Think about it. A2. Wait, why am I thinking so much? Why am I thinking so much? I could do it like this. And linear solve. Come on. Dude, shut up, Jaden. Fucking E1 maybe. We call it E1, which is matrix 0 minus 1 minus 4 3, and we've got sorry. Oh, okay. We'll call this U1. We'll call this E1. E1 is 1 0, right? And then we'll do with linear algebra, linear solve, open bracket U1 augment E1 close bracket gives us that. Some ugly ass coefficients, but there's no way in hell I would be able to kind of like figure it out. Yeah, come on. Then Alpha 1 equals minus 3 over 4. Beta 1 is equal to minus 1 over 4, right? And then for this one, it's the same. We've got that, 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 that. Linear solve once again. Then you've got alpha 2 is equal, beta 2 is equal. Okay, we'll just do it. U2 is that and that. Okay, so they keep using U1. We'll define U2 as 0, 1. And then we'll do linear solve again. Open bracket U1, augment E2. And we get minus 1, 0. Okay. So now we have minus 0, 4, minus quarter, minus 1, 0. And then find a matrix such that Tx is equal to Px. 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 Okay. It says find the transformation, or turn this transformation into matrix. Well, you've got E1, E2 into the matrix. And each E1 and E2 is defined by alpha 1, alpha 2, right? Basically. Right? Then you actually have two vectors like that. Like that, which gives us this. Okay. I think we can just do it from here. Minus 3/4, minus a quarter, minus 1, 0, double bracket. Nope, doesn't work. Doesn't work. Don't work. Don't work. I'm close. I can feel it in my heart that it's going to be all ow, ow, ow. 'Cause the player is going to play. It's alpha 1 B1. So maybe okay. You know how we expand stuff like in the X and Y direction? It's like some alpha 1 beta 1, alpha 2 beta 2, you know? And then you have your vectors. And they like expand it this way and this way. So maybe if we group it like this, then we might have like minus 3 like that, like that. Sorry. This. Okay, we try this, okay? Minus 3/4, minus 1, minus a quarter, 0. also wrong. Okay, I've got linear transformations, and we've got the scalars. It's not these guys. Okay, we'll go into our algebra section, and basically, well, Milan Pohor has just, oh my god. These guys should just shut the fuck up. They've been texting nonstop. Wait, I remember. If I add all of it together, then I get it. Then I get the vector. Jesus. Jade, no. No, you don't. 3/4 of that gets me. Okay, let's try it. 1, 0 is equal to minus 3/4 times 0 minus 1 plus a minus a quarter and minus 4/3. Okay, let's say if I do it, then this one would be 0 here, 3/4 here, plus, sorry, minus 3/4 here, plus 1. What the fuck? Here, this is what I thought. The vertical assemblage of the transformed standard basis vectors and pre-multiplying a vector by a is the same as transforming the vector. So the vector a is the transformation of E1. Have I been given E1? I have E1. I found the correct coefficients. What do these coefficients want to do to me? Transformation on E1, transformation on E2, transformation on whatever. TE1. Okay, how does E1 get transformed? Does it tell? No. I've been given E1. I've been given E1. And it's equal to some alpha times some beta, plus some beta, sorry. Two other vectors. Two of the same vectors. But it's not alpha 1, alpha 2, beta 1, beta 2. Could it be E1, E2, B1, B2? I don't know. You tell me. I know I'm supposed to multiply or line up the column vectors together so that I can create the linear transformation. But how do I do that? West side, renegade, renegade, renegade. Wait. You can show it to me in LaTeX. It's just that when I'm writing the stuff, I don't want it seen in LaTeX. So this looks really ugly. Explain what you just explained again. I I think this question and maybe one more question. I think I'm losing steam. Getting quite sleepy. God, there were 10 questions. More like 9 because we started on Q2. But if we do this 3 hours, that means every question took around like 20 minutes to kind of sit through. And mind you, our exam is 60 minutes, 60 points. So we have 2 hours. Each point is 2 minutes. So I'm taking about 3 times the normal thing to basically just like figure it out by myself. And by the second run, the time gap reduces massively. Yeah. How do you... What? That is sick. Whoa. My God. T incorporating looking at values on the board T of, well, to find some T of X is equal to P of X, and P is matrix T is transformation. That's okay. T of the matrix is equal to T of E1, T of E2, T of En, right? So T of E1 is equal to T10, which is actually T of minus 3/4 times T of 0 minus 1 plus minus 1/4 of T of minus 4/3. Okay. The fuck? That's pretty sick. Yeah, no one's figuring that out first time around. Here, you've got 0 minus 1. Sorry. 0 minus 1 gets transformed to 0, 1. Oh my god. Sorry, 1 0. And you've got minus 4 3 gets transformed to minus 3 4. Then you have our guys, which is minus a quarter. Okay, this is getting a little bit. Minus a quarter times plus 3/4 or 4. And you get you get minus 3 over 4, 0, plus 3 over 4, 1. Is that right? Minus 1. Which is equal to 0 minus 1. So t of E1 is equal to that. That's gnarly. I've never... What the That's goated. What the hell? Okay. Alright, let's do that again. Clean cut right there. Then we do a second run, which is number 2. Which is T01 is equal to T E2, which is equal to T of fuck. Minus 1 times T of 0 minus 1 plus 0 T of minus 4 3. One more time, just to be clear. Yerp. Cancels. We get TE2 is minus 1 times 0 minus 1 is 0 1. So P is given by the matrix of TE1, TE2 is equal to 0 minus 1 and 0 1. Should be our answer. Shit. This is not. No. Because we haven't really transformed it. But we have cleared this. But then this one needs to turn into 0 minus 1 is 1 0. This one becomes minus 1 0. So P is given by the I'll remember this next time. Okay, which is the y on x flip. But it's negative as well. Okay, let's take a look at Mobius. That's the reflection. I need you to generate an image for me so that it's for my notes, but it's going to be a list of square matrix transformations, preferably things like I'm going to read them from left to right and then like a book, you know? It's like the 2-on-2 matrix -1001 is the transformation, which is like the flip of uh the y-axis, right? Which turns the any positive x into negative and a negative x onto the other one. Then there's like the transformation onto the y-axis. Then I also want um, reflection across the origin, which is -1, 0, 0, -1. But then also the reflection in y of x, like y is equal to x. And then uh, uh, in the reflection of y, y is equal to -x, which is the other flip. Tons more, but yes, please go for it. Generate the images. Wait, shit. I never let go, and I get high with them, baby. Well, we see a squared minus x form, right? And it's in the square root as well. And so immediately in my head, I'm like, okay, x squared, sorry, yeah, x squared minus x squared, sorry, minus x squared, a squared. Is that right? Is that how I used to remember my algebra content? And this would be like a sine and a hyperbolic tangent one. Do you have to revise it? But this would be a tangent and a sine one, and this would be like a cosh and a cosh. Okay, so they use the sine one, which is exactly what we thought of, fortunately. Is it minus? Okay, so this is, and this is minus a. It's just for me to kind of remember these tools they give you. Okay, FTDT, right, which would be 4 cosine t. And then the integral GT, what did you 4 cosine t? What we start off is we start off with this integral, right? X squared. Sorry. Then we let x is 4 sine t, dx is equal to 4 cosine t, dt 4 over 16 sine square t times 16 minus yeah, 16 minus 16 sine square t, right? Still dx right now? Or should I do 4 cos dt? Then we have, I'm trying to remember how to integrate 1 minus, sorry, we're gonna pull 16, maybe 1 minus sine squared. Ah, shit, my phone, my shit just died, but that's gonna be cosine squared. Actually, yeah, it'll be cosine squared. And it'll be sine squared here, and it'll be 16 cosine t dt. And then we'll pull some shit out. I never let go, and I get high with my baby. With my baby, yeah. I get high with my baby. Results in got. What's got again? How would I remember what got is? Cotangent is. It's one of the worst ones. How do the cos matter? I forgot. Cosec is. It's. Oh. Cotangent's 1 over 10, right? Yeah. I remember now. Or cosine over sine. So much of this. In order to write this term in the terms of x, it is convenient to draw a right triangle. Oh, okay. These are okay. Oh, this is. Oh, he's fucking whoever. What's his name? Terry would cook these papers. He would cook these papers. Let's see if I can mental math this. So that's 4 cosine. Okay, I got it. 4 cosine squared. This is 4 times cosine t dt times 16 sine squared t, which is equal to 16 cos t dt over 16 sine squared dt times 4 cos t. Cancels. Yep. 1 over 4, 1 sine squared. Yep. T. dt. They want me to keep the quarter inside. There's a negative sign here, but that's because they integrated from cosine down to sine. It's fine. We'll do a quarter times 1 over sine squared t. So quarter times 1 over sine open bracket sine squared t. Something like that, maybe. Okay, that doesn't work, so we'll just do sine t squared. We're missing something? Yep, we're missing a parenthesis. There you go. And then, in order to write this in terms of x, it is good. Ah, shit, where the fuck? So, integral is equal to cot 4, right? Which is equal to cosine over sine divided by 4, which is minus cosine t over sine t 4 sine t. Yeah. The lengths of two sides of this triangle are non-constant, and it gives you that one of these equations is equal to x. The length of the third remaining side is a constant integer. Find this integer right there. I'm given cot t, and I've got x is sine t. X is 4 sine t. I've got cos t. And they want me to draw a right triangle. I remember Terry doing this, but he did it like so. Still, he's cooked it. Like so catois, bro, but like t represents one of the acute angles. Two lengths of the sides are non-constant functions of x, and is given to you that one of these is equal to x. Fuck, I don't remember how to do this shit. He does it really fast. You start off like you're thinking like, okay, well one is x squared. It's like a squared plus b squared is equal to c squared, or x squared plus something squared is equal to, or x is equal to c, a is equal to c squared minus b squared. You've given me the integral. I know that x is 4 sine t. Whoa, I see 4 sine t right there. Oh my god. That's equal to 4 cos t over x. Okay, I don't remember how to do it. I don't remember how to start to compute the triangle. I need you to logically walk me through it. Well, I know that, like, let's say minus cotangent of t over 4 is the same as minus cosine over sine divided by 4, which is the same as minus cosine divided by 4 sine t, right? And x was the substitution for 4 sine t. So we got minus cosine t over x. But I keep forgetting. Okay, let's say if I set the angle t as an acute angle, then the opposite of that is going to be, sorry, if I want to find the length of the other one, if I don't find the length of opposite to t, it would be I don't know, it'd be both ways. But it would be cosine t, right? Opposite over adjacent would get me cosine t. Cosine t is equal op over adjacent. Like, I don't know where to put the x, the t's, and all this bullshit. Why do I not know how to do this question? What the fuck, Jaden? Oh my god. That's really clear. You start with this. X is 4 sine t. Okay. And you're looking at the triangle, and you're like, okay, how do I get 4 sine t? You're like, well, that means sine t is equal to x over 4, right? And it's equal to opposite over, sorry, and this is so, yeah, so, and this is equal to opposite over hypotenuse. So you've got x here, and you've got hypotenuse there. Therefore, a is equal to, or sorry, a squared plus x squared is equal to 4. So a is equal to x squared minus, sorry, 4 minus x squared. A is equal to 2 minus x squared. Sorry, 4 squared. Man, I'm a dumbass. 16 minus x squared. Okay. Okay. So start with equation for x from initial x substitution, right? Once you've got the equation for x, then use trig given in this one to find value of trig equation in terms of x. Then op over hype and find the two sides. Remaining side is equation for Pythagorean. Pythagoras. Right. Am I a dumbass? Probably. I've got cotangent and I've got x is equal to 4 sine t. Then sine t, right? sine t is equal to x on 4, which is equal to opposite over hypotenuse. If we draw this triangle right here, right, and I gave this as t, the op over hypotenuse is x over 4. Sorry, 4. And you've got adjacent here. Then a squared plus x squared is equal to 4 squared. So a is equal to 4 squared minus x squared. Right. Then it says length of third remaining side is a constant integer. Find this integer and write it in the box below. Oh, I found it. Right? Then this is equal to 4 squared minus x squared, and this is x squared, and this is 4, and so this is 4. 4. Okay. It just says right. It says write it in the box. It's more inequality work, is it? Use the change of variables. The integral can be rewritten as okay. U squared minus 3u, right? U squared is equal to e to the 6x squared, which is equal to e to the 2 times 6x, which is e to the 12x. And 3u is equal to, 3 times e to the 6x. Okay. Okay. What's wrong? Why is that wrong? F-U-A-U, hey, who-a-you, friends and they need to. Are my power laws all fucked? My power laws all fucked. Think. What type of trash person am I if I can't do this question? What? Looks like I'm running out of steam. I can't even think properly now. Last question, I go to sleep, guys. Hey, baby. Yeah, looks like I gotta sleep. 3, right, u squared minus 3u times 1 over 6e to the 6x, and this is equal to u, which is equal to that's right. 6u times the whole load of that. Ah! Why he don't like that? Because I didn't multiply here. Yep. 6u times u squared minus 3u. That's okay. Now, using standard partial fraction decomposition, the function 1 of u becomes a sum of how many terms? Oh, looks like we could do like 2 terms, right? This is a term, and this is a term. You wanted me to do 3 terms? Why? Is that why they wanted me to do 6u squared u minus 3? But that becomes a linear, right? This becomes a it's catching up to me. Zero practice. Fractional decomposition. Integration techniques. Trig. Sec and cosh. I did not do that. I did cosine and cosh. Not good. Partial fractions. Integrals. This one. It has to. It just has to be smaller. Linear, poly, constant linear, constant poly. Yep. Oh, you're right. Here. I have to remember this one. 3 terms. And this is the weird part. It's so weird. It's so weird. I don't know why. We view it in the simplest way possible, and thus it is linear. Thus we only need constant at the top of the decomposition, but the carrying be thinking of possibilities. By stepping through the powers when establishing the template. We are still treating all 3 denominators as linear, and so we must need only constants on the top. We also need to recompose with care. This is the weird part. Decomposition with decomposition with things that are with larger multiplicity. So we have 1 over 6u squared times u minus 3 is equal to 1 a plus 6u Wait, I need to explain the multiplicity one on the fraction decomposition. It's like 6 times u and then 6 times u squared and then u minus 3. So is that the 3 different terms that you would split it up for standard partial fraction decomposition? And then y? Why? Just why? Okay. Okay, let's break it up. Boom. 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 Okay. First step. This one has multiplicity 2, so it must be a plus a b plus c over u minus 3. And then, I mean, we have to compose it in a way where if we add it all back together, it must cancel out. And so, like, a must be multiplied with uh, a must be multiplied with u squared times u minus 3 plus b has to be multiplied by u times u minus 3, and then c has to be multiplied by u times u squared. Basically to cancel everything out. Is that right? So weird. So the value of a u squared b u squared is equal to that. I already know the value of a. I don't know. Oh. But is this right though? It's okay. Let's look at the way he does it. Here, that's how he does it. He sets it up in a way where it's like you have the whole denominator on the bottom, and then you try to form this try to decompose it this way. And then you have these set as the left-hand side questions. And then you're solving. So, like, is this right? It's like, if I divided u squared times u 6, yeah. Sorry, I'll just take the 6 out. But I would only want to divide by, I have to divide by just u to make sure that becomes like boom, 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 which is equal to AU. And this one has to divide by like u squared, u minus 3. So it just has to be like that. And this one has to be like u squared, u minus 3. And it must meet this expectation. So it's just like that. Boom, boom. So A u minus 3 plus b u minus 3 plus c u squared is equal to 1. Test u is 0, right? Then a times 0, b minus 3, and c 0 is 1. So minus 3b is equal to 1. B is equal to minus a third. Fuck! Yeah, and then for me to decompose correctly, like, I'm setting up an equation where oh, this is so ugly. Quarter divided by quarter times u, maybe? Such an ugly term. Sum a over use is the same as being divided by 6u times 1 over 6 is the same as divided over 6. So, okay, let's do minus quarter over 6u. Bring everything to the top. Wow, that's ugly. Think about this for a sec. Therefore, you must include every like no. Last question. Come on. Oh, 操！我很累啊，但是明天我可以finish，因为我 already have fucking 12 questions in a few hours. So tomorrow is finishing up core group, and it's off to the races we go. Let's finish my water.
Argentines